Hello, my favorite people. Welcome to our first ever lesson. This lesson is one of the fundamentals we need in mathematics, the real number system. In WAEC, there are a lot of ways we represent our numbers. Even in real life, we have ways of representing numbers. The way we represent numbers in classrooms is different from how we represent numbers in the engineering field. It's also different from how we represent maybe in the hospitals or in other areas of life. So in this our lesson, we are going to look at how WAEC expect us to represent our numbers. Hence the topic real number system. So in this topic, we'll be looking at various definitions of the types of numbers we have, the properties of some numbers. Then going on, we'll be looking at rounding of numbers, the significant numbers, the decimals, and other operations associated with the number system. To begin with, you start off with our definitions. The first term I would like us to define is natural numbers. Natural numbers. So as we can see, natural number is any number that begins from 1. Natural numbers begins from 1, the number 1. This is because if I enter a classroom, assuming this is your classroom, and I enter, and I ask the class rep or the class prefect to start counting the number of students in the classroom, I believe he or she will begin from 1, 2, 3. So he or she is done counting, right? Yes, so you could see that natural flow. It was natural. When I asked him to start counting, he started naturally off from 1. That's why natural numbers begins from what? 1. Natural numbers are also called counting numbers. So they are also known as counting numbers. And I believe you know why they are called counting numbers by now. Because they are naturally used to count. Like I said, your prefect started counting from 1 and then they start from 0. I don't think anybody will start counting human beings from 0 before moving on to 1 to 2. So when we say natural numbers, these are numbers that begin their count from 1 up to infinity. I believe this is clear. So natural numbers, I will repeat, they begin from 1, and the clue that you can use for natural numbers is that they're also called counting numbers. Therefore, we also start counting from 1. We always begin our counting from 1. So natural numbers are numbers that begin their count from 1. And in the set system, they are denoted by n. N being a set of natural numbers. So you can have n is equal to a set of natural numbers starting from 1, 2, 3, 4, 5, and so on and so forth. These are natural numbers. If there is any confusion or there is any misunderstanding, you can leave it. You can leave a comment in the comment section where we will address this issue. The next definition we want to look at is whole numbers. Whole numbers. A whole number. Now, these are numbers that begin from 0. So whole numbers begins from 0. Let's note the difference. In counting numbers or in natural numbers, they begin their count from 1. But for whole numbers, they begin their count from 0. I'll give you an example. For example, if you have an exam or if you have a test, it is possible for you to score 0 over 10. It is highly possible for you to score 0 over 10. This is because we need the whole marks, the whole of the marks, which begins from the scratch, which is 0, all the way to 10. But this is the case, you had 0. Unlike natural numbers or counting numbers, where we can't count human beings as 0. Items or things like your marks or your distance covered or the height, such things can fall under whole numbers because it could be you could score 0 over 5, or you haven't covered any distance, so 0 kilometers, or maybe the height of a thing is on the floor, so 0 centimeters. Though these two are somehow tricky, but the whole point of whole numbers is that they begin their count from 0. That's why we will have 0 0.1, 0 0.2, 0 0.3. All these are less than 1. These are less than 1. Remember, 1 is the starting point of natural numbers. 1 is the starting point of natural numbers. And 0 is the starting point of whole numbers. So with that said, W is the representation of whole numbers, capital W. So therefore, we can just begin off with 0, then 1, then 2, then 3, and so on and so forth. So as we can see, we can find our natural numbers in here. We can find our natural numbers here just with an addition of what? 0. So when you have our natural numbers plus 0, we have our whole numbers. That is the relationship between whole numbers and natural numbers. When you have our natural numbers with addition of 0, we have our whole numbers. I believe this is clear. Now, we move on to another type called integers. Integers. Now, integer is any positive or negative whole number. It's any positive or negative whole number. That means we can have positive integers. We can have positive integers as well as negative integers. So if you say positive integers, that means that positive integers, and it should be a whole number. That means we have 1, or positive, let me put the positive 1, positive 2, positive 3, positive 4, and so on and so forth. For our negative integers, we can have negative 1, negative 2, negative 3, negative 4, and so on and so forth. But in mathematics, whenever we write a positive integer, we don't append the plus sign. So this plus sign, we usually don't append them to positive integers. It's only negative integers that we are extremely careful of. We have to show that this is a negative integer. So now, if we combine our positive integers to our negative integers, we have integers as a whole. But don't forget, they are whole numbers, so we need our 0. We need the 0 as well. So let's say onto the right of the 0, we have the positives. And onto the left of the 0, we have the negatives. Up to infinity. So this becomes the set of integers. And the set of integers is represented by z. Z, we saw that natural numbers was n, whole numbers was w, and integers now becomes z, which starts from, let's say, the infinity, negative infinity, to maybe -3, -2, -1, 0, 1, 2, 3, and into the positive infinity. This is what integers talks about. So now we can see that integers has natural numbers, has whole numbers, and has negative integers. It has the positive side and the negative side. That is integers. If there are any questions or there are any misunderstanding, let us know in the comment section, then we can address them appropriately. With that being said, we move on to the next definition. Odd numbers, or I believe let's start with even numbers. Even numbers. Even numbers. We are all familiar with the definition of even numbers. Now, these are numbers that when you divide by 2, will leave a remainder of 0. Or these are numbers that you can divide by 2 exactly. There is no remainder. So numbers that are divisible by 2, numbers that are divisible by 2, leaving out no remainder or no remainders. So when we say an even number, it's a number that's when you divide by 2, there will be no remainder. For example, if I have 4 oranges, orange 1, orange 2, orange 3, orange 4, and I divide by 2, I believe everyone is going to get 2, 2. So for the first person, we have 2. Second person, we also have what? 2, right? So we had 4 oranges and we had to group them in twos. So we group this one in twos and another one in twos. We could see there was no remainder left. There was no remainder left. So we can say 4 is an even number. We can say 4 is an even number. You can try with other. So let's say so we have, let's say we have 6. So our group 1, 2, 3, 4, 5, 6 divided by 2. So take note, to test if a number is an even number, always divide by 2. Always divide by 2. So now let's group them. I group my 2, I group another 2, I group another 2. There's no remainder, and you can see we have 3 groups. That means 6 divided by 2, we have 3, leaving out no remainder. Therefore 6 is even. Let's try with another example. So here I have 5. So I'm going to group, let me use rectangles, triangles this time around. 3, 4, 5. We want to check if 5 is an even number. So we have to divide by 2. Now let's group them in twos. We group the first 2. We group the second 2. Unfortunately, we find out that there is a remainder. There was one triangle remaining. So that doesn't satisfy our definition of an even number. Therefore, 5 is not an even number. 5 is not an even number. So to quickly go through even numbers, these are numbers that are divisible by 2 without leaving any remainders. So we tested with 4. We had 4 oranges, 4 circles, and we decided that we are going to group them in twos. And after grouping them in twos, we found out that there was no remainder left. Therefore, the number 4 is even. Then again, we tested with 6. So we had 6 oranges. We grouped them in twos. And after grouping them in twos, we realized there was no oranges left again. So 6 is even. Then we tested with 5. In grouping them in twos, we realized after grouping them, we had one triangle left. We had one triangle left. We couldn't group it in two. So we concluded that 5 is not an even number. I hope and believe this is clear. So if we are to list even numbers, we can say 2. Let's see if 2 divided by 2 is 1, remainder 0. So I believe 2 is part of our even numbers. 3 divided by 2, so that is 1, remainder 1. So you could see there was a remainder left, so 3 is not part of even numbers. Then we move to 4. 4, I believe we did it up there, which was part. 5 is here, it's not even, so we move on to 6. Now if you look at the pattern, you could see that even numbers, they begin from 2. Even numbers begin from 2 and they increase by 2. So that means 2 plus 2 should give me the next even number, which is 4. Plus 2 should give me the next even number, which is 6. Plus 2 should give me the next, which is 8. Plus 2, which should give me 10. And so on and so forth. So even numbers begin from 2 with an increment of 2 to fetch the remaining numbers. So you could see you have 2 plus 2, 4, plus 2, 6, plus 2, 8, plus 2, 10, plus 2, 12, and so on and so forth. Now, one may ask, how can I identify an even number? It is very easy to identify an even number. So we have to know this. Basically, if you have this at the back of your mind, the first 4, if you have it at the back of your mind, it will be easy for you to identify an even number. So how to identify an even number? So 1, any number ending with these, any of these, 0, we'll talk about this one. So let me put an asterisk on it. Or 2, 4, 6, 8. Any number ending with any of these is an even number. Any number ending in any of these is an even number. So for example, 22 is an even number. 34 is an even number. 576 is an even number. 1008 is an even number. Good. Now, the 0 over here, I kept an asterisk because for that, the number should be 2 or more in digits. I mean, it should be something like 10 or 20 or 200 or 2000, right? Or 30, 50, something like this. All these are even numbers. But the number 0 itself is not an even number. The number 0 itself is not an even number. That is why I kept an asterisk over here. So for 0, it should be 2 digits or more. So here you can see you have 2 digits, 2 digits. Here we have 3 digits. Here we have 4 digits. Here we have 4 digits. But for the single digits or 2 digits or any other digits, if they end in 2, 4, 6, 8, they are even numbers. So you could try that. Let's try an example. I'll just guess a number. In 2020, Yes. Let's divide 2020 by 2. We could see the answer we get if you are using your calculator is what? 10, 10. No decimal, no remainder. So this 2020 is an even number. The next one is 58. You could see it's already ending in an even number. So divided by 2, rest assured, this is also going to be an even number. So 58 equal to, so here, if you use your calculator, you are going to have 29 as our answer without any remainder. That shows that this is an even number. I believe this is clear. Yes, you can always rewatch the video if there are any misunderstandings, and also you can use the comment section to let us know the difficulties you are facing. The next definition I would want us to talk about is the opposite, or the twin sister of even numbers, called odd numbers. Odd numbers. So that is the twin sister of even numbers. So with that said, I guess you already have your definition in your mind. So odd numbers are numbers. These are numbers. These are numbers divisible by 2. Yes, they are also divisible by 2, but there's a catch. These are numbers divisible by 2, but leaves a remainder of 1. Leaves a remainder of 1. So that's the catch. That's the catch. Even numbers itself, they are also divided by 2, but leaves a remainder of 0, or in other words, no remainder is left. But for odd numbers, also divisible by 2, but now leaves a remainder of what? 1. Let's take a look at this number. Let's use our previous example. I believe we used 5. So 5 triangles divided by 2. So now we are going to group them in twos. I group my first 2. I group my second 2. Now you could see this rectangle was left. And how many was it? Just 1. Just 1. Just 1. So that's why odd numbers are numbers divisible by 2, but leaves a remainder of what? 1. There is no way it's going to leave a remainder of 2. If it leaves a remainder of 2, that means you are not done with the grouping. Assuming, let me go back with the 5 again. Assuming I have 5 divided by 2, and I group my 2, I group my 2. You can see it's left with a remainder of 1. But assuming we had another triangle here, and you tell me, no, the remainder is 2. This can be possible because you are not done grouping. If the remainder is 2, then that means you can group them again. And that makes this an even number because now there's no remainder left. I hope you are not getting confused over here. The remainder that should be left should be either none, which is 0, or 1. So if it's left with 1, then we can peacefully say that that number is an odd number. But if there's no remainder left, then we can peacefully say that even that number is an even number. That is it. Like I said, even odd numbers are like a twin sister. It's like a twin sister to even numbers. So then how do you identify odd numbers? So any number ending in this 1, 3, 5, 7, 9. Any number ending in this, any number ending with any of these is an even number. Sorry, it's an odd number. Forgive me for that. So for example, all these themselves are odd numbers. So if I add any number, for example 11, now it becomes an odd number. 13, and you could see Just as how even numbers moving from one to the another, it was just an increment of 2, 2, 2. Odd numbers also begins from 1 and has increments of 2, 2, 2, 2. So 11, 13, if I have 29, it's an odd number. If I have 37, it's an odd number. If I have 105, it's an odd number. So any number ending in any of these is an odd number. I believe that is clear. So if we are to do last example in testing our understanding of odd numbers, I would choose the number 7. So 7 arranges 1, 2, 3, 4, 5, 6, 7. Now divisible by 2. So let's group them. Let's see how many remains. I group my first 2. I group these 2. I group these 2. Now you can see there is a remainder of 1. That means 7 is odd. 7 is odd. I believe this is clear. If there is any misunderstanding, you can leave a comment down there so that we can address your issue. Next, I would want to talk about is the factors of a number. Factors of a number. I would want to touch on this and explain 2 more definitions, then we can draw the conclusion. When you say factors of a number, so for example, if I have 4, as a number, so this is the number we are talking about, factors of a number. So now we are saying factors of 4. It means any number or all numbers, let me put it this way, all numbers that are divisible by 4 without remainders. No, let me put it in a nicer way. I like to use simple English so that we understand. So factors of 4, they are numbers that can divide 4, without remainders. All numbers that can divide 4 without remainders. So when you say factors of 4, that means there are certain numbers that can divide 4 which won't leave any remainder or remainder 0, in other words. So for example, let me list some numbers to see if, so I'll list 1, 2, 3, 4, and let's see which of them can divide 4 without leaving any remainder. So now let's begin with 1. We are testing if 1 is a factor of 4. So let's go. 4 divided by 1, I believe is 4. Remember what's 0. So we can safely say yes, 1 is a factor. 1 is a factor. Let's move on to 2. 2. 4 divided by 2 is 2. Remember 0. So then again, yes, 2 is a factor. Let's move on to 3. 3 divided by 2. Sorry. 4. Should rather be focusing on our on our number, which is 4. So 4 divided by, checking if 3 is a factor, 3 is equal to 1, remainder 1. So you could see, since we had a remainder over here, 3 is not a factor. Then we have the last one, which is 4 itself. So 4 divided by, checking if 4 is also a factor, is what? 1, remainder 0. And since there was no remainder left, 4 is a factor. So yes, we have identified our factors. We have identified our factors. And what are they? So there are factors of 4. Factors of 4 are 1, 2, and 4. Note, for 3, we had a remainder of 1. 3, we had a remainder of 1. So that can't be a factor. So we had these to be the factors of 4. Let's try another example. So we can have let's say 6. Let's try to find the factors of 6. So maybe we can list all the numbers up to 6. Then we try one by one. So 6 divided by 1 is 6, remainder 0. Therefore, I consider 1 to be a factor of 6. We move on to 2. 6 divided by 2, which is 3, remainder 0. I therefore consider 2 also to be a factor. We move on to 3. So 6 divided by 3, which is 2, remainder 0. So then I also consider 3 to be a factor. We move on to 4. So 6 divided by 4, which is 1, remainder 2. No, unfortunately we have a remainder. Therefore 4 is not a factor of 6. We move on to 5. So 6 divided by 5, which is also 1, remainder 1. And unfortunately, since we have a remainder, 5 can't be a factor of 6. And the last one, which is 6 itself, we have 6 divided by 6, which is 1, remainder 0. Since there was no remainder left, 6 is a factor. So now we can safely list our factors. So we can have 1. So those in green from this section are factors. Those in green, 1, 2, 3, and 6. So these are what we call factors of 6. 1, 2, 3, and 6. These are the factors of 6. I hope the explanation to factors are clear. Now there are more tricks in finding the factors of a number that we will cover in the next lesson as we progress through this course. So if you haven't yet subscribed to this channel, you subscribe and make sure you hit the bell icon, and I'll see you in the next video.